Is my screen visible and am I audible?
Yes, you are visible and audible.
Greetings everyone present here. I am Gautam Alangam. I'm a PhD scholar from Department of Geography, Manipur University. Today I'm going to present a study titled Long-Term Temperature Trends and Warming Patterns in Mountainous State, a spatial to temporal perspective from Manipur, India. In the introduction section, according to the World Meteorological Organization, as the Earth warms due to the increased greenhouse gas emission, climate change is causing uneven warming rates between land and ocean. Mountain areas in the tropics, including the northeastern India, are experiencing rapid warming compared to the rest of the regions. Long-term temperature change is an important indicator of climate change. It's more pronounced in mountainous regions like Manipur, located in northeastern India. This study uses the high-resolution graded temperature datasets to investigate the long-term trends and patterns for understanding regional dynamics, and this study also includes the spatial mapping to visualize the distribution and variation across the states. Following are the objective of this study: first, to examine the changing patterns of temperature fluctuation and variation in Manipur; second is to study the trend and temperature in the state; third, and finally, to understand the spatial and temporal distribution of temperature across the study area. This map shows the location of the study area, also the elevation differential in the study area. Coming to the methodology, daily temperature data were obtained from the ERA reanalysis version 5 data from 1940 to 2021. Since the data obtained were in NetCDF format, the data processing was conducted to convert into CSV and Excel for further data analysis. Data analysis was completed in three sections. First, the descriptive analysis to observe the statistics such as mean, standard deviation, and coefficient of variation. Second is the trend analysis. The non-parametric uh, trend analysis techniques such as Munn-Kendall and change slope estimator were applied. Munn-Kendall is to observe the monotonic trend, that is whether there is a consistent rising or falling pattern, and change slope estimator measures the magnitude of the trend. Also, the Petit test was applied to identify the abrupt change or shifts in the center of the time series dataset. And finally, in the GIS analysis, inverse distance weighting technique was applied to show the spatial distribution of temperature over the different time periods. Table 1 shows the descriptive statistics of the Manipur. Since we have seen that all variables of the temperature have low standard deviation and low coefficient of variation, which indicates a low fluctuation in the dataset. Also, in the table 2 shows the trend and result of the trend analysis at the conducted at a significant level of 5%. There is a significant uh, value of MK test statistics, and also the change slope estimator shows that there is an annual increase of 0.016 degrees Celsius for minimum temperature, 0.020 degrees Celsius for maximum, and 0.017 degrees Celsius for annual mean temperature. The figures in the top are the warming strips of temperature. Warming strips are very simple yet powerful way to show the changing temperature over the time. Each stripes represent a year, and blue represents a cooler and red represents a warmer year. As we move from left to right, we have uh, visually captures the increasing pattern, which is validated by the temperature variation by the graphical represented in the graphic figures below. And this is the result of the Petit test, which identified 1985 as the change point of minimum temperature, 1992 as the change point of maximum temperature, 1984 as the change point of mean annual temperature. Uh, the temperature datasets was divided into two distinct periods based on the change point identified by the Petit, and following are the spatial distribution of the temperature. Minimum temperature in Manipur from January to December. The warming is more intense from March to November, while western and southeastern regions show the most consistent and significant in minimum temperature. The months of March, April, October, and November exhibit the most pronounced spatial shift towards a warmer temperature. Coming to the maximum temperature, it has increased in every month after the change point. as in the second period, and the greatest increases observed in April to September, and also in the western and the southern districts. And, and for the mean annual temperature across all months in the second period shows a noticeable shift to warmer temperature compared to the previous period. March, April, and May showed a strong warming shift over 2 to 3 degrees Celsius. September, October extend warming and delayed seasonal transition, and western and southern regions saw the most pronounced increase in the mean temperature. Coming to the conclusion, the result revealed a static and significant warming trend across all three temperature variables. Among the variables, mean annual temperature exhibit the most consistent trend, while the mean temperature showed slightly greater variability. The increased temperature has been steady over the decades, with low standard deviation and coefficient of variation indicating a gradual and persistent warming. Thank you.
Thank you, Gaurav. And I would like to ask Dr. Neera to kindly unmute and present.